Alright, another draft science production. So we're still on the subject of interference, generally speaking, and the complexities of the subject created when you compare the different ways of creating patterns in signal transmission. That's what we could call it. And that this theory of wave-particle duality and this ability of photons to be disturbed by a medium they're traveling through, it gets complicated. Okay, so what the two-slit demonstrates, the key feature of the two-slit experiment was the single photon version. As that told you, the property is the photons are really interacting with a ghost of themselves. They're not interacting with each other. They're interacting with some thing they do to the field, and then the field does something to them. So it's kind of like gravity in the sense that the bent space, the matter bends the space, and then the space reacts with telling the matter how to move. Kind of crap stuff. Theory. So you're stuck with that as the underlier here. So when you talk about the effect, you can't really talk about it in the sense of drawing these two waves from two different signals, because in theory what's going through one slit isn't being affected by what's going through another slit, because in theory the single photon went through both slits. So you'd almost have to argue that the same photon is coming out of both transmitters somehow, or something, to have a consistent theory. Because what's coming out of the transmitters, the two transmitters, are their own set of photons, individual photons. And there's no evidence in the two-slit experiment or single-slit experiment that photons are interacting with each other. The theory is they're interacting with some mechanism created when they move past a medium. Yeah, see, I mean, there's no way to make sense out of it. When they go through slits, they do this thing. You're saying I don't have to make them go through slits. I can make them do this thing by sending different photons and having different photons interact with each other. And there's no evidence that that was happening in the single or double slit experiment. That's what Huygens does. Huygens says the photon's interacting with itself. It doesn't say it's interacting with another photon. So there's real problems here. And all this glossing over, these are big questions. So I did write all the questions down. The text is below. I'll attempt to read them and qualify them because they're more complicated than the text I've even put in the questions. The underlying theory, and I want to play some of the original video again because there's other parts that just doesn't make any sense. And then Holiday's video doesn't make any sense. I mean, he was talking about question 5. Why the 1/4 difference? And he says it's not an important question. I mean, to me, it's almost elephant in the room kind of question. I mean, it's glaringly needs an explanation because it really can't be explained, in my opinion, by any diffraction theory or any theory of interference. Even though Professor says somehow it's fundamental to the process of interference that there's this huge difference in the intensity when you cover one of the slits. It really isn't. Anyway, in the center. So what else did he say? Alright, so yeah, he wants me to show the, I don't know what I wrote here. Show, blah, blah, is this bullets? Oh, show bullets. Well, that's what I'm attempting to do. I'm attempting to find a way to do an experiment that will demonstrate, without any doubt, bullets. You're saying there's a bunch of these duality experiments that exist out there. I'm saying there really isn't. There's a bunch of experiments that can be explained with alternative explanations. So this radar experiment, for example, yes, there could be this explanation where you say somehow these individual photons are not individual anymore, and they're interfering with each other in some way and creating this wave interference pattern. Or you could argue that just two signals are jamming each other, and that's what's killing the signal. So when they're out of phase, they jam each other. It's just as viable an explanation. Anyway, you're not going to be able to see the jam in the sense that when the frequency is destroyed by the jamming, you're not going to be able to see that it's there because it's jammed, it's ruined, it's been broken. Okay. Let's see. The proof. Okay, so yeah, so he was talking about in this part of his video, right before this part, how if I can do this thing, if I can defeat this radar experiment by demonstrating that no, it is in the receiver where the problem lies, and the signals are essentially jamming each other. They're not interfering, they're jamming. And yeah, so I can prove that, and I've done this Nobel Prize worthy thing, but I would argue that no, that really won't work, because the people who are really two-slit devotees will say, well, that wasn't a real two-slit experiment anyway. I mean, quite obviously it isn't. And it was a wrong premise to start with, and they'll just say, well, Professor Lewin was wrong. Physics wasn't wrong. He was just wrong to think this experiment could duplicate the two-slit experiment because, yes, you don't have individual photons interfering with each other. Obviously, when I shoot one photon from one of the emitters, that photon isn't going to interfere with itself. So somehow I haven't maintained the two-slit mechanism. And again, I would argue that this is also true in the sense that that argument is true because, as I'm pointing out, the only thing that makes the two-slit phenomenon happen, or the single slit, the Newton's rings, is the fact that it's a medium, the matter. The photons are going near the matter has electrons, the electrons are deflecting the signal. There's no electrons in this experiment, so in the way to do any distorting, so the signals go straight. Okay. Alright, so anyway. Alright, so the thing I noticed in Professor Lewin's video is, in the beginning, he talks about, oh, well, I could do the experiment with the phase different. And I was thinking, wait a minute. Everybody always talks about how none of this stuff works if things aren't in phase. The interferometer doesn't work. The big huge one they made, right? The Lego thing. I talked about how they spend a huge amount of resources on trying to get the laser beam precisely, on phase. No phase shift at all. That's really important. And certainly the argument's always made in the slit experiments. There's, well, clearly the single photon will always be in phase with itself. So if it splits, so to speak, it does its field thing, its ghost. When it creates its ghost to interfere with itself, the ghost is going to be exactly in the same phase it is. So it's always, the event always takes place with two objects in phase. And so you can retain some theory that photons not in phase can't do this interacting. And that explains why two laser beams can't be forced to create a divergent pattern by crashing the two laser beams into each other. It won't work. And there had to be a reason why it doesn't work, right? By theory. And the theory is though they're not in the same phase. But if they were in the same phase, they would Newton ring each other or something. I'm just saying, this is, this gets quite contradictory, and it lacks all coherency. There's not coherency between these theories.
Two radar waves will kill each other. Essential for the maximum to be here is, of course, that the two transmitters are in phase. We could have rigged it up so that they're 180 degrees out of phase, in which case there would be silence here.
Okay. So he's conceding the argument that the silence takes place because the two are out of phase. But he's also conceding that I don't need them to be in phase to interfere with each other. So they can be out of phase. So you could argue that instead of 180 degrees out of phase, you could have them 90 degrees out of phase. And you'd still get a pattern, but like the maximum would be here, and the next maximum would be here, and they'd all be off at wrong angles to each other because of that shift in the phase. But again, that defeats the argument of how important phase, being on the same phase, the single photon interacting with a duplicate of itself, a clone, that essentially has the same phase. And that the argument would be the reason why we don't see this effect commonly is because the sources of photons are never in phase. So that's glaring.
Silence in this case means that the radar would kill the radar. But I do use the word
so the radar would kill the radar. So again, you know, he's saying it's happening in the atmosphere between the two transmitters. They're killing it here. I'm arguing, no, it's killing it at the receiver. Because the receiver is stuck with it combining two out-of-phase signals, and so it lost the frequency. It's now twice as high a frequency signal, because now there's photons, there's voltage where there shouldn't be voltage. So it's voltage against voltage against voltage. There's no down, there's no empty spot to define the frequency.
Science for a good reason, because the way we rig this up is the same way we did it before. We modulate this 10 gigahertz signal with a 1000 hertz audio signal. We call it amplitude modulation. And the receiver, which is here, receives the 10 gigahertz radiation, which is modulated at 1000 hertz. We feed it to an amplifier, we demodulate it, and you will hear the 1000 hertz. And so we can also move it along this track here and find the location x1, whereby we have our first maximum apart from the zero. And I found that that is very roughly at 15.6 centimeters. And you should confirm that using those equations. The equations are the same, whether you deal with sound or with red laser light or with gigahertz. Makes no difference.
So again, he's saying it's all the same phenomenon, and clearly I would argue that that's really subject to debate. Clearly going through slits is different than two transmitters.
And so let's turn now to this demonstration. I will turn on the two transmitters, and here's the receiver, which is...
Okay, so again, you can see that this is exactly the same speaker, the same table, the same setup in the other MIT experiment that Hoffladay provided. The only thing missing is the oscilloscope.
Exactly at angle theta 0, so there's a maximum. I'm now going to close one transmitter, put my hand in front, and you think about what will be the reduction of intensity of the sound here. If I close one, it's substantially down. You may think that it is down by a factor of 2, because we have only one transmitter instead of 2. You're wrong. If you think that, you do not understand interference. It is 4 times lower when I hold my hands over one. Figure it out for yourself.
Yeah, well, I think you should have helped, Professor. It's really figure it out for yourself. Thanks. You know, how generous of you. So in the context, remember that in the other MIT experiment, the guy did exactly the opposite. He had the receiver at the point where the two signals interfere with each other, and then he covered one of the speakers, and the signal was really, really loud, which is a contradiction. One speaker covered, you can barely hear the thing. When the other guy covered one, it was loud as heck. So another, what the fuck? How do you make sense out of that?
I'll test you on the final to see whether you really understood that. So now the sound is 4 times larger than when I cover one up. I'll cover the other one up. It's down by a factor of 4. I can cover...
Okay, so I just wanted to do that. I mean, you know, for us today to dismiss that as some kind of nothing point, it seems pretty glaringly in need of explanation. Alright, so let's see, I think I've covered what I need to cover, so I'll get to the text. So these are my questions and such. Do you agree that if there is a wave property, it is possessed by the individual photons and is not a manifestation of any group behavior? That the wave property is held by individual photons and is not the byproduct of collective behavior? So clearly there's a theory here. And the theory demonstrated by the two-slit experiment is that single photons manifest the behavior. They don't need to be in a group. They don't need to interact with any other photon. They manifest this effect just interacting with the atmosphere. That's the theory. Okay. Having passed through a slit, somehow that motivates them by Huygens' principle, in the sense that somehow their wave function is interfered with, and now they turn into multiple waves, multiple photons, essentially, wavetons, whatever. Alright, question 2. The signal as transmitted is just made out of positive photons, and there are no negative photons or negative signal. So this is just making the argument that I'll briefly go over it one more time. What's happening is the signal is sent out as a frequency. So in 1/zillionth of a second, okay, a certain number of photons is emitted, and they all shoot out at the inverse square kind of ratio. But anyway, they all shoot out at that one instant. So it could be a million, or so we'll just say the 1,000 for the sake of the argument. And then at a specific timing cycle, so after a little bit of time passes, then another sliver of photons at another density, that this could just be 500 of them, and then there could be just 100 of them at another exactly the same time interval. And that's what's going through the air, is a density of photons. The antenna receives that density hits. So at a moment of time, the first one comes in, the 100 hits it, and in this zillionth of a second, a signal sends down here a voltage. It's converted into a voltage. So 100 would equal, you could say, 10 volts, and 500 would be 500 volts, and then 1000 would be 1000 volts, just for the sake of there's a clear measurement. The voltage will be consistent with the number, the density of the photons released and the density that hits the antenna, and that the antenna will convert this digital signal of weight, this weighted on-off, into a weighted velocity that becomes an AC current, in the sense that it will create a voltage that indicates this is how much photons hit in that zillionth of a second, and then it will get the rebound, which will be the opposite voltage, and this will tell it which way this one will go, the vectors. So one vector indicates the amplitude of the voltage. I guess the other one I should draw this way, and the other vector will indicate the response, and that will end up being visualized as a wave of positive and negative, an AC current, and later this will be cut off, and then you'll just go back to having of an empty space and a voltage quantity. And that's it. Then that'll be your signal. Alright. So the signal is just made out of positive, so there's nothing in the atmosphere that's negative. It's just photons, no photons, photons, no photons. It's just a density of photons and then the opposite of no density. So it's just a plus number and a 0. Okay. I mean, is that agreeable? Next. Question 3. Where is the interference happening? In the atmosphere between the emitter and the receiver, or at or in the receiver? Can the receiver properly interpret two signals? How can you tell where the interference took place? What's the proven test? So it's just the basic argument that they're saying the two emitters are creating waves of photons, and that these waves of photons, even though we know it's supposed to be individual photons, are interfering, creating waves of interference. I'm not drawing this very well, in the sense I'm not, and that these lines would be your constructive interference, and the other lines would be your destructive interference. The other places where they meet. And that's what's creating the dead spot. So the dead spot's being created here in the atmosphere, where the photons are somehow, photon plus photon equals no photon, kind of a thing. I'm doing that the wrong way because these are the wrong lines, but let's just say the other lines are here. Anyway, and I'm arguing that no, what's really happening is there's two signals coming in, and when they get out of phase, it means the two signals are, when you smash those two signals together, what you end up with is this signal ends up being right inside of the part that's supposed to be defining the wavelength of the other signal. So you end up with, instead of 4 bars per 1 second, you end up with 8 bars per 1 second. And that's not going to work. That's not going to be the same frequency. So the signals are jammed. So this probably requires somebody who knows more about these circuits than either me or Hothladay in terms of specifics about what happens. So part of that question 3 would be, what do you think happens when two equally strong waves come into a radio antenna? So from two different sources, source A, source B. They send the same amount of intensity to the antenna, the same frequency, and the only difference is, so the two signals have exactly the same amplitude. Alright, they're the same strength. The only difference is they're out of phase. So what happens to those two signals? Does the circuit choose one, or does it somehow combine the two? And if it combines them, it's going to destroy the frequency. That's the consequence of combining them. So it really can't. It has to choose one. One would argue. One has to win, one has to lose. And can that be tuned? Because it's tuning to a frequency, but it can't really tune to phase. But you might be able to argue that phase is a subcategory of frequency, and that technically you could tune to the phase of the frequency. Maybe that's a possibility. I just don't know. I don't have the answer to that question. I don't have enough knowledge of the specific, what the circuit's capable of. So that'll have to be answered by somebody who knows. So anyway, so we don't have a proven test for that. Like I said, if the signal is being jammed, how would you know it's being jammed? How could you detect the fact that there's two signals coming in and you can't separate them? Because you can't, the original signal's ruined. So how can you know it existed? Alright, question 4. How does the inductor or oscillator, or as Hoffaday would say, the resonant circuit, distinguish between two different signals at the same frequency? Okay, but at different phases. So it seems 4 is the subcategory. It doesn't really make sense, but okay, yeah, it's a more specific question, asking the specific question just about how would an oscillator be able to distinguish between two different signals at the same frequency but at different phases. Okay. Number 5. Why does covering one of the emitters reduce the signal strength 4 times? So that's the question just illustrated. How do you explain this in light of the fact that the signal at the second maxima is almost as strong as the signal at the first? So that's an important thing to understand, that the strength of the signal when he moves it to the second maxima is almost as loud as it is when he has both emitters. So it's 4 times here also. The signal is still 4 times stronger than just one at this location too. So this can't be a central maxima function because it happens at all the maximas. So the idea that in the double slit experiment, or even more obviously in the single slit experiment, one has the anticipation that the photons going directly through the middle probably aren't going to get affected as much as photons going closer to surfaces. But that's more consistent with my theory. Anyway, you can't use as an excuse the fact that some photons go through the slits without being interfered with. So you'd be stuck with the theory that they all get interfered with, if what he's saying is true. Alright, number 6. Yes or no? The voltage of the circuit represents the number of photons that hit the antenna at the target frequency. So this is just to get to Hoffaday's direct accusation that somehow you can't represent the number of photons as a voltage, and it's just saying, come on, you get this, right? If the photons hit, they'll create a certain voltage. The voltage will be an expression of how many photons hit. Anyway, yes or no? The antenna creates an AC voltage, and the circuit will remove the negative portion, leaving a null space, which will become the blank space between the positive signals defining the wavelength and frequency. Okay. So I know there was a 7th, but I don't know what happened to it. I don't know whether it's worth attempting to retrieve it. But yeah, I think there's enough questions on the table, and like I say, I've gotten to this idea that having two signals out of phase is somehow okay with him. He's saying they don't have to be in phase to interfere with each other. And so that's another consistency rule it seems that's being broken in this new version of the experiment. Alright, so we'll just play some more of Hoffaday and retire for the evening. I don't think I missed anything else I had to get to.
But if I turn my mind to it, but it's just not really that important in this principled discussion we're having. I think.
Yeah, well, I'm just saying. I think it's pretty. Like I said, first the inconsistency between the two experiments. Like I said, the other MIT experiment kind of demonstrated exactly the opposite. That the speaker was very loud with just one transmitter. So it just doesn't make much sense.
You know, as I watched your video, I understood that going over some of the problems I thought would explain a lot of those questions that you were asking. But if apart from that question 5, which you did reiterate and summarise and go back to,
yeah, well, I didn't hear any answers from you about any of these subjects. Sorry, I didn't. And your blanket statement that somehow there's a whole bunch of experiments that are decisively proving something, either bullets or waves. My whole argument is that no, we don't have an experiment that does any of that decisive stuff. They're all wishy-washy. They all create, your whole theory is dependent on this Huygens stuff that's creating an infinite number of something that's breaking fundamental physical laws. An infinite number of something in a confined space. I mean, these are fundamental rules you're just breaking for the sake of this, and you're saying, well, this is some sort of decisive evidence of it must be a wave because of this experiment. Well, I don't see the must part. And I don't have a hard evidence of the bullet theory. I mean, hard evidence in the sense that you can't come up with a wave explanation. I mean, Newton and Huygens had this argument. Both of them had valid theories, and then, the decision was sort of made when they found out that light transmits through glass or water slower rather than faster, because Newton believed it had to be faster for his theory to work. And that's sort of like it's sort of an erroneous reason, because if Newton knew ahead of time, he would have probably conformed his particle theory to faster rather than slower. He could probably do the same thing going either way and make it work. So, it's just these arbitrary things that are deciding what theory is valid or which one wins is just arbitrary. I would argue that Feynman's raindrop analogy against particle gravity, in the sense of it creating that ether drag, the point could be argued that only exists if, just like this wave theory, there's no, obviously the electromagnetic field doesn't create any ether drag, so it can be negated by just creating an explanation that says, well, no, the things that are moving perpetually have an engine inside that moves them perpetually. And I would argue that matter can do that, because matter traps force, and force has perpetual motion. I mean, it's not, there are viable explanations.
The rest is at a basic questioning level of reconciling whether there is such a thing as basic wave-particle duality. Right?
Right. Well, I'd say that underlying this conversation is people who say duality is silly. So, on the face of it, yes, one or the other has to win, because duality is idiotic. It's creating way too complicated a reality underlying the mechanism. So you're basically just having you're just basically creating Peter Pan world or a God world, a heaven. You're saying, okay, forget this physical reality shit. The underlying mechanism is, yes, we're only doing this earth thing so we can go to heaven. And you're basically saying that physics doesn't get simpler going down. No, it gets layers of huge complexity. And it doesn't make any sense, because that complexity would have to leak into this world. And it doesn't.
Like I said, wave-particle duality is normally explained in the context of two-slit experiments. But the recent video you've discussed and talked about, Waterlooing, is actually a demonstration of at least the wave part without the two splits.
Well, again, it's not really the wave part, because we know that the two-slit experiment only works on individual photons. The individual photons are doing the interfering with themselves. So again, you're forgetting the premise of the two-slit experiment in terms of what carries the wave function. The wave function is carried by the individual photons. They're the ones that have the probability wave. So you can't have it both ways. You can't say they have an individual wave function, and when I feel like saying it's okay for them to interfere with each other, they can interfere with each other. I mean, you can't have it both ways.
And you're just denying even that. And
Yeah, I'm always, like I said, I never saw any real evidence of any wave, okay? So I'm just saying there's no evidence that photons wave. Every experiment, except ones where you strangle the photon, where you force it to go through some weird thing or do some weird thing, those are the only times you come up with any reason to believe it's any kind of wave thing. And now you're saying again, like I'll point out again, now you're saying, no, it's not the individual photon interfering with the electromagnetic field and changing its direction. No, it's interfering with other photons. And now it's groups of photons. So the wave has gone from being an individual photon thing now to being this group of photons is going to interfere with this group of photons. So now you took it away from being one photon gets interfering with itself. You now converted it into, no need for Huygens anymore. Now, no need for Heisenberg, no narrow gap here, no real problem. Now it's just, yes, photons interfere with photons, and groups of photons interfere with groups of photons. My consistency is not in jeopardy here. Your consistency is.
Without good reason, I think, in the context of their own theory.
Well, see, without good reason in the context of their own theory. Well, as I just pointed out, none of this is consistent with their own theory. Show me the single photons interfering with single photon theory. Draw me the diagram of how the single photons are interfering with themselves in this two-transmitter experiment.
I believe, ultimately, there is something else going on. Something physical going on. And the wave characteristic is emergent from something else going on.
Yeah, okay, so you're demanding I give all kinds of details. How does the circuit do that? How does this circuit, how does it cut that off? How does it blah, 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 blah? And you're just saying, well, I think there's something, sort of, yeah, maybe something happening. Again, mockable duplicity.
So, yeah, I get what you said about, waves aren't travelling down the wires, right? But we speak that way, and I expect you to understand that what I'm saying is that there's a voltage curve, and the voltage amplitude is rising. That's a given, yeah? We both understand that.
Well, it's good. I mean, we agree on that it's an AC. This is where it's converted back into an AC circuit in the sense that it has a backward and forth motion, a plus and a minus. So it's going from a digital signal back into a plus and minus signal, a wavy signal. This is the wavy part, right? A plus and a minus movement of the electrons.
It's just a way of talking to me. But how a wave in an electrical circuit means the voltage is varying all the time. And how...
yeah, well, see, that's always another tricky part of this, right? Is because we can always say that there's only such a thing as a positive wave. We could just say there's no negative wave. We're just going to count the positive humps, and we'll still call that a wave, even though technically it doesn't have the depression part, right? And so that's sort of another one of these problems with the word wave. This is really just a digital signal when you just have the top humps. And it's only turned into a wavy thing when you put these bottom pieces on. But again, those get cut off by the circuit. So the circuit turns it back into a digital signal for sending to the speaker.
Sound wave in air means the pressure is varying over time. What we mean about a wave in light is that the electromagnetic force...
yeah, well, there's no point. See, electromagnetic force doesn't say anything. So this interaction that this photon has with an electromagnetic force has never been demonstrated. You can't move a photon with magnets. So again, it just doesn't make any sense to talk about this charged field force, a force that's completely dependent on charge, electricity and magnetism, and then you're going to talk about a particle that has no charge being intimately associated with these charge fields. I'm not supposed to say, that's not supposed to ring a bell of, well, that's not very, no continuity there.
Of the electric field, or the combination of the electric and magnetic.
Why don't you just stick with the pressure part? Okay, you got the pressure part here, right? Just understand that what photons do is they hit electrons, and the electrons are tied in tension, and that creates pressure. That becomes a medium. The medium is all the electrons are tied to each other magnetically. You can't move one of them without stressing every other relationship that exists. And that's what's turning it into a wave thing. Because now there's a medium to disturb. And so that's the pressure. And so when the pressure hits, there's the equal and opposite reaction. I mean, if we just agree on that, then we've made some progress.
Is varying with time. So the thing I was saying that it used to puzzle me is that some long, I think maybe hundreds of meters, long wave radio is perhaps hundreds of meters, but let's say 10 meters, okay? We can have a radio wave of 10 meters. And what used to puzzle me...
yeah, well, they say so many things that aren't really right? Because they say, I read someplace where it said something like, like AM signals cling to the ground. And I was saying, that's not right. Because from what I understood they did, in short wave, the longer wavelength radio, was that it bounces off the atmosphere. Because of the long wavelength, it bounces off clouds, it bounces off all. And so it's only staying low because it's constantly bouncing off the atmosphere, where the the higher frequency waves, photons, end up going through the atmosphere, so they don't bounce off of it, so they have a shorter range. So you can only send FM signals like 40 miles, where you can send AM signals like 300 miles, because the AM will bounce off the atmosphere. But see, they say things like it clings to the ground. You're saying, well, how the hell does it cling to the ground? So I mean, they say things, and you're saying, who thought that was the right way to say it? Maybe it's true, but I'm just saying it's not what I understood, and I'm still not convinced. Somebody's going to have to show me the theory of how the AM signal gets stuck to the ground.
That was never discussed, and was important to be discussed about understanding. And I think they probably just don't know. That's probably why they don't talk about it. But what is one photon? Is one photon always one wave in the orthodox theory? That's one question. I'm not...
Yeah, well, see, my argument is, of course it is, in the sense that it's one photon separated by a distance before you get to the next photon. I mean, technically you can't, you have to have a minimum of 2 to create a frequency. But you could argue that you could have 3, and that would be 2 tons. And if you had 4, that would you only need 3 tons. You see what I'm saying? I mean, so the number gets smaller and smaller. So it's really one photon. It's really a one-to-one relationship. But when you just have, say, 2 photons, it doesn't look like a one-to-one relationship because there's only one frequency, wavelength, between them. But as soon as you add another one, like I said, then you can start to get down the relationships 2 to 3. Okay, and then you add another one, then the relationship is 3 to 4. So, it keeps getting better and better as you add more and more tons in the string. But yeah, it's a one-to-one relationship. There's a ton, a thing, and then there's the space, and then a thing, and then a space, and then a thing. I mean, how, it is, you can analogize. I'm not saying you have to believe it's bullets. I'm just saying you can perfectly analogize what a frequency is with bullets, and what a wavelength is with bullets. The analogy works. The metaphor works.
Such that if we say we are long-wave broadcasting of 10 meters or 100 meters, are we saying we've got a photon 100 meters long?
Yeah. Oh, see, obviously I would be saying no. We have a photon that can have a distance, and we're going based on the speed of light. How the meters is really just how long does it take at the speed of light for the second one to show up, and at the speed of light it takes that distance. So it seems like a lot, but yeah, that's sort of the precision of the universe, right? That photons coming at such a long distance from each other are going to hit exactly the same location somewhere. And that's after traveling, say, 10 billion light years through space, and they still have that much accuracy. But that makes sense. The universe just doesn't have a bunch of error code built into it. The existence of the universe might be error, but once the universe exists, everything precisely does everything. There's no, it just moved funny.
So I think that's unlikely. So the photon must have correspond to some section of energy with accounting for this value here.
I'm just saying that there's no need in having this conversation with me, because I'm saying until you show me how the metaphor fails. The metaphor of just saying the photon is a cannonball and there's a distance between the cannonballs. The metaphor works. You have to show me how that metaphor fails before I need to have some sort of like, well, how can this be possible? Because to me, it's exactly it defines a frequency. The distance between the cannonballs.
And the next photon has less energy. But this makes no sense.
So, less energy photon, again, no such thing. So you can, you know, the energy is being defined by how distant they are from each other. How far apart the cannonballs are from each other is defining the energy. The energy isn't in the cannonballs themselves. The bullets are all moving, the cannonballs are all moving the same speed. They all have the same mass. They're all the same. The only thing you can change is how many are hitting in a period of time. And obviously 4 of them is going to equal more energy than 2 of them in the same amount of time. So obviously the ones at a higher frequency are going to seem like, okay, they have more energy. But they individually don't. The cannonballs don't have more energy. The cannon expelled more energy in shooting 4 of them.
Because a photon of a different energy is a different frequency. The energy of it. So this, I think the
so again, you're just not stay consistent with the metaphor. So quit trying to turn it into a thing that you stretch or something that you energize. Stay consistent with the bullet theory or the cannonball theory, and don't let go of it, and you'll see it'll always work. You can always make it work.
What Steve implies that you get photons of 100 meters long, and that's why, you know...
No, you get distances 100 meters long. Empty space between the photons 100 meters long. I can shoot a bullet now, and I can shoot a bullet an hour from now. There's no rules.
You know, perhaps, I don't know, 10 meters, you know, or you get long wave radios where you have huge aerials, and you have to have, you know, this 10 meter long photon can only be absorbed if it's exactly a quarter the length of the, or half the length of the wavelength or something. This stuff is a mystery to me. And it's confusing and it's rarely explained.
Yeah, well, I think that has more to do with the fact that the length of the antenna has more to do with how the potential getting through the antenna from the impact of long wave radio. So in the sense of the electrons having to send the signal that ends up, it probably has to do with that rebound part, right? It has to have a longer distance to travel for the rebound signal, okay, to come late enough to create the negative part of the signal that you're going to cut off anyway, which would be the space. So it's a matter of reception. You can't receive it with a small antenna because the rebound happens too fast.
and the way it is explained, or it isn't explained, the way it's dealt with, is because, as I said back here, right, is because of what it means, the wave-particle duality. The experiment sets up to detect waves, and the experiment sets up to detect particles.
Okay, so he's doing it again, saying this. I talked about this part before, but he's saying this is somehow a real thing that's happened, that there's these really hard evidence and really hard evidence for these two theories. And no, I'm arguing that all of these experiments, none of them have been decisive. This is a really small thing. We can't see them. We can only see the side effects created by them. So it's really hard to make an experiment that you can, where we can find, if the truth was obvious, then this wouldn't be a subject, right? This wouldn't be a controversy if it was obvious, because Benjamin Franklin would have found it, or Newton would have found it, or somebody else would have found the experiment that reveals the truth. So obviously it's not a truth that's easy to find. And it's even like the laser beam thing, right? I mean, my brain was saying, yes, laser beams go lasery for a long distance, and they really don't. They're diverging. So why do they diverge? Why can't we make light that runs parallel? And then I think about that argument and I say, well, that's probably part of this whole movement problem. Everything's always changing. It's always in the process of having its velocity changed. And so it's constantly, that readjustment in all these different ways is mushing through us. That's waving through the medium of us, making that decision. We don't have instantaneous velocity. We're not hard bodies where something hits us and we immediately move. No, the thing, we absorb momentum, and it takes a while for that momentum to work through us and come up with a decision. And so that's why light diverges, is because every second, every millionth or billionth or trillionth of a second that a photon's being created, the source moved a little before it shot the second little bit.
Depending on the setup, all they do when they're talking about the wave functions is talk in terms of waves and the way it works with waves. They never try to reconcile the quantum aspect. They really...
Well, let's be honest, okay? I don't think anyone really believes in the duality, all right? You think Piro really believes in a duality? No, he thinks it's waves. He thinks there's an electromagnetic medium and these things are waving through it. So, I mean, there's no, and I definitely don't think there's any duality. I think it's definitely particles, and they don't have any wave function whatsoever. They don't do a damn thing. They go in a straight line from point A to point B until they hit an electron. That's it. The cannonball flies through the air. It doesn't hit anything. So unless there's a bird flying by, the cannonball is going to go where it's going.
Speak about both. So that's what I'm
a really big bird.
But you, with good correct motivation, are trying to speak of both. But that's been the problem of physics for the last 100 years, is that nobody's managed to do it. And so I'm just in good faith telling you what you've not explained, what's not working.
Blah, blah, blah. And in good faith, it doesn't mean anything. I'm pointing out how their experiments are flawed. I'm pointing out how their theory and what they're claiming, they're claiming this was proof, goddammit. He's claiming this fucking experiment proves something. I'm arguing against that claim that he has proven something, for fuck's sake. And you're turning it on me saying, well, you haven't proven the bullet theory. Well, that's not my obligation. My obligation is to stop him from saying, we proved it was a wave. He said in the damn video it's a wave. He said Huygens was right. He said Newton was wrong. He said these things in the fucking video. I mean, fuck. You're just not getting it here. You will not criticize them, ever. They're the ones with the huge gaps in their fucking evidence. I point them out, and then you point your finger at me and say you didn't prove it was bullets. I don't have to prove it's a bullet to say they can't say they proved waves. Damn it.
What you've not provided enough detail of?
Again, I don't have to provide detail of anything. I'm claiming they don't have proof. I'm saying their evidence is shit. You can't see that. They're showing up in court with a plastic, a black and white drawing of a gun. Well, this is the drawing of the gun I think I saw on the floor. That proves he shot her. They're doing something like that. Why do I have to bring in counter evidence of him, a videotape of him perpetrating the crime or something, to claim that that piece of evidence is a piece of shit?
And so, I finish and summarize again. How is the full aspects of an electromagnetic wave theory expressed in photons?
It's not. Okay, so it's that simple. It doesn't happen because photons hit electrons. Electrons have the wave property in the sense that electrons do the push-pull thing. The move here, move back, move here, move back. That's a function of electrons. It's not a function of photons.
When you first said it, well, that light has different frequencies and it's given by pairs of photons at a distance arriving. Yeah? That only accounts for the periodic feature, function, property of a sine wave. But now as our discussions have got moved on to...
Well, again, you're saying it's a sine wave because an oscilloscope shows something like a sine wave. But that's not the truth. That's an obligation of the mathematics, the algorithms used to make the drawing. It has nothing to do with the fact that that could just represent the fact that there's a positive 5-volt voltage, and the only way it knows how to get the negative is to draw this line. But the fact could be that it's just that there's a peak, and that's it. And like I said, this negative peak would only be the rebound thing. This would never travel through the air, this negative ton. So this is the only one going through the air. There's no wave. It's just it either is a quanta of energy or it's not a quanta of energy. That's what there is going through the atmosphere. There's a quanta of energy in a location, all right, there. No, none of this Heisenberg crap. It's there. It's going to land here eventually. And the only thing that distinguishes, like I said, these photons from other tons is the fact that they are at a frequency. And we can detect that. And electrons can feel that difference.
Radio wave propagation, we've realized that this explanation...
I hate this. We have realized. Piero does it all the time. We. I just would love to know who you're weeing with your we.
It's too simple. And
again, another blanket, crap, vacant, vacuous argument. There's nothing, it's too simple. No, it's perfectly satisfactory. It doesn't need to be complicated. It's not too simple. You have no proof, okay, that anything more complicated travels through the atmosphere. No proof that anything more complicated is necessary.
You've had to suggest, a completely different system. And as I say, I went through it, that you have problems because...
No, I don't. Because again, you keep thinking I have to have, height and width. I don't need the width, fella. Unnecessary.
You either ditch this original notion,
again, there's these preaching about what I need to do. So again, they make claims, they've proven wave theory with an experiment that is really, like I said, with a bunch of unanswered questions lingering over it. And here you are telling me how, if I was doing your theory, this is what I would do. Now, I don't need your help, thank you. Again, I'm going to argue that if you just go through it, show me how Cannonball doesn't work somewhere, and give me a specific example how Cannonball doesn't work.
Trying to keep with it, well, it generates problems and paradoxes, because what you're saying is that within a certain time interval, as I explained before, what we're really dealing with is bar graphs of quantities of varying widths.
No, we're not doing this width thing. Again, this is the third time. There's absolutely nothing I ever said about any width of a voltage. It's a voltage. the photon is converted into a voltage representation. The number of photons that hit create more voltage. It's one line going up. It could be thin as a hair. It doesn't matter thickness. The only thing that matters is height, voltage. There's nothing else. There's voltage. Period.
Because if this is time, you can't have a bar chart of quantities of photons with the same time, because this is in contradiction. If you say, I've been through this before, but
you've been through this before. You haven't said anything rational here. I mean, it's the third fucking time you brought it up, and it's irrational gibberish.
You say 100 photons are here in 1 picosecond, and you said there's 200 photons here in 1 picosecond. That is a violation of the notion that the definition of the light at a frequency is a pair of photons.
No, it isn't, because that's what hit the antenna with the photons. This is a representation of the voltage that equals how many photons hit the antenna. God damn it, the photons aren't doing a bar. The photons are all coming at one time. They hit the antenna. They create a voltage. What is so complicated about that? A pressure on the antenna. They hit the antenna with a certain pressure. If there's 200 of them, it's more pressure than if there's 100. The more pressure, the higher the voltage. Period. End. No fatness involved.
It's a regular space, because you've had to compact them quicker to get 200 in the 1 picosecond as compared to...
Again, no. Compact what? It's voltage. Up. Not fatter, higher. Fuck.
The 200, the 100 is the 1.
Yeah.
You have to...
Fuck you, I don't have to. I don't have to fix your stupid straw man arguments. I don't have to have solutions to them. Again, instead of pointing out how, yes, you're entirely correct, there are huge unanswered questions, what did you do? You glibly just washed over the 1/4 reduction in the signal strength. Oh, who cares? That doesn't mean anything. Who cares that the slits were about single photons interfering with themselves? But no, we don't need to worry about that. Instead of recognizing the 7, 10, whatever points it is I have made here, and acknowledging their evidence is far from anything you could call a proof, instead of acknowledging that, you're doing this nitpicky crap that's a complete straw man. That has nothing to do with anything that I have to resolve, because, damn it, you keep thinking the height can't change. And so you have to make things fatter. I mean, fuck. Your argument is complete crap. And you've completely ignored all my good arguments about how their proof is far from a proof.
You have to have the notion of bigger bar graphs, varying times. And as I said...
No, I don't have to have any such fucking notion. It's not in a single drawing I've drawn. It's nothing. There's no need to do it. Look, longer, 1,000, longer, 500, shorter, 100, shorter, less density. Nothing about width. Although that can be expressed as width, it just doesn't have to. Again, what's hitting an antenna doesn't have to have any width to it. And as I pointed out, there can be some variation. That's what the sideband filters are for. But we're talking about a billionth of a second width.
That complexity would feed into the electronics needed to do that. And let's not forget that all the while, there has to be an account for